Hello, good morning, students. In the last lecture, we had studied about classification of organic compounds on the basis of carbon skeleton. Now we will study this homologous series. So what is this homologous series? So we know organic compounds are there are variety of organic compounds. Many organic compounds are there. So a similar type of organic compounds, a similar group of organic compounds, they are written in using a general chemical formula, and this type of series is obtained. This type of series is called as a homologous series. The definition of homologous series is it is a series of organic compounds in which the each successive member differ from each other by a constant difference of methylene group, and methylene group is CH2 group. So this type of series of organic compound is obtained, that is called as a homologous series. So a family of functional group, that is a same functional group containing series of organic compound, is a homologous series. So in this series of organic compounds, they have same carbon skeleton, same functional group. Only difference is that each successive member, that is differ from its next member, adjacent member, by a methylene group, that is a CH2 group. It is called as a methylene group. So this type of series is called as a homologous series. Now each member in this homologous series, it is called as a homolog. For example, we can consider a very simple example of homologous series is a alkane. We know there are alkanes, one type of open chain organic compound having general formula CnH2n plus 2. And very simple example of alkane we know is a methane having molecular formula CH4. So methane, ethane, propane, butane, pentane, like this, many alkanes, they form a homologous series. So that is called as a homologous series of alkane. Now each member, individual member in the homologous series is called as a homolog. What is homolog? Individual member in the homologous series is called as a homolog, and all the members or the homologs of such series are represented by same general formula. Meaning is all organic compounds in one series have same general formula. Then other characteristic of homologous series is they possess similar chemical properties and gradual change in physical properties, meaning is melting point, boiling point, density and solubility. They goes on increasing with increase in number of carbon atoms and number of hydrogen or other atoms in the series. Here one example of homologous series given is homologous series of aldehyde containing straight chain with general formula CnH2nO. In this formula, N is number of carbon atoms. So in table number 14.4, here the homologous series of straight chain aldehydes is given. So names of these members of the homologous series are formaldehyde, acetaldehyde, propionaldehyde, butyraldehyde, and valeraldehyde. In this general formula CnH2nO, the N number is number of carbon atoms. In formaldehyde, N number is 1. In acetaldehyde, carbon number is 2. Propionaldehyde, 3 carbon. Butyraldehyde, 4 carbon. And valeraldehyde, 5 carbon. So the molecular formula is CH2O, then C2H4O, C3H6O, C4H8O, C5H10O. In this molecular formula, only difference between any two members is of CH2 group, that is methylene group. And here the condensed structural formula will be for formaldehyde HC double bond OH, for acetaldehyde CH3 C double bond OH, for propionaldehyde CH3 CH2 C double bond OH, for butyraldehyde total 4 carbon atoms CH3 CH2 2 times C double bond OH, and for valeraldehyde 5 carbon containing is CH3 CH2 3 times C double bond OH. So this is condensed structural formula for first 5 members of straight chain aldehydes. Now, in the characteristics of this homologous series, we had studied that this gradual increase or the gradual change in the boiling point, melting point, density, then solubility, like this property. Here, the example is given as a boiling point. See these boiling points, carbon number 1 containing aldehyde, it is minus 21. 2 carbon containing 21 degrees Celsius, 3 carbon containing 48, 4 carbon containing 75, and 5 carbon containing 103 degrees Celsius. If we observe these values carefully, then it is very clear that this boiling points goes on increasing. So there is a gradual increase in the boiling point as number of carbon atoms increases. So that is about one example of this homologous series of aldehydes. This is the second example of homologous series of alkane. In this example, one carbon containing alkane is a methane having molecular formula CH4. 2 carbon containing alkane is a ethane with molecular formula C2H6. 3 carbon containing alkane is a propane with molecular formula C3H8 and condensed formula CH3 CH2 CH3. Similarly, butane, pentane, hexane, heptane, octane, nonane, decane. Like this, there are many examples of this type of organic compounds can be given in the homologous series. If you observe carefully from the propane onwards, if you observe the middle carbon, it is a CH2 1 times. In butane, it is a CH2 2 times. In pentane, CH2 3 times. In hexane, CH2 4 times. That is, here by increasing CH2 group at each stage, we get the next member of homologous series member. So it is very easy to write the homologous series members like this type of examples. We will study many examples in hydrocarbon too, that is alkane, alkene, alkyne, aromatic compounds. Like this, we can write many examples of homologous series of different organic compounds, and that is about homologous series. Thank you.